Hello friends, welcome back to Trabstructive. In this video, we are going to be discussing about some basic signal in signal system. There are several types of signals in signal system that we'll deal with. One of them is the unit step signal. This unit step signal is very important because it is one of the signal we use in making transformation, in making some certain operation in signal system. Let's look at what it is. The unit step signal is also known as if side function. That's another name for it. It is also known as if side function, and it is denoted as u of t, right? From the name unit, right? That's for unit step signal. Now, this kind of signal is defined for some certain region. What is the region? Now, it has a value of unity, as it is said, unit, right? With a value of 1 and 0 elsewhere. Now, the region where it has a value of 1 is from 0 up to infinity. You see, from the origin up to positive infinity, that's where it has its value, and it keeps going that way. For t less than 0, which means the negative region, it has a 0 value. Now, you might ask, what is the application of a unit step signal with this? One of the application of unit step signal is that, as you can see, it only exists in the positive axis and not in the negative axis. So we use it in the case of what? Truncation. Truncating of signals. For instance, let's say we have a sine wave. The sine wave is moving this way. It's occurring both on the positive and negative region, right? By mixing it with a unit step, right? If we mix it to a unit step, because from the word unit it has a magnitude of 1, so it isn't going to affect the signal. Actually, we are just mixing it with something of unity, and the response we are going to get will be, this will result in a signal only in the positive region. You get it? We neglect the signal in the negative region. You see that the way it works? That's one of the use case of what? Unit step. Let's look at the second signal, which is also very important in signal and system. The second one is the unit impulse, right? It is the unit impulse. It is also known as the Dirac delta function. It is very important also in signal and system. It is denoted as s of t, or you can like Dirac of t, this way, kind of like Corley x, right? Now, this signal is defined for one thing. It has a magnitude of 1 and 0, and the magnitude of 1 only exists at the origin t equal to 0, and it has a value of 0 elsewhere. So meaning that at the origin, if you look at the signal at the origin, we have a magnitude of 1, and everywhere else, both on the positive and the negative axis, right, it does not have a value. Now you might ask, what is the use case of what? Of a unit impulse. Now, the use case of a unit impulse works this way. Let me give you an example. Assuming we went to the market to buy watermelon, right? You know, the way watermelon is, and you want to know if the watermelon is good, right? Watermelon. You want to know if the watermelon is quite good. What do you need to do? For those that know how to purchase a good watermelon, they only take the watermelon and hit the watermelon, they tap it, right? With just a single tap to see if actually there's water in it or if it is actually good, right? So that tap you apply to the watermelon to know if it is good, it's also the same function unit impulse does to the system. Assuming that we have a system, right? Assuming we have a system and we want to know how the system works without affecting the system, without applying something very complex, we just want to know how the system responds. So we apply a Dirac, right? A unit impulse. So when we apply the unit impulse to it, we get an output in terms of, let's say, y of t, right? So when we get the output, that output tells us about the system based on the impulse signal we applied, because we applied something, and the thing we apply isn't going to affect the system. It's not like it is adding something to the system. No, what it's actually doing is that it is just defining what the system is all about. It's just a single tap, right? If you look at it, it only exists at the origin for a short period of time, like a spike. That's one of the use cases. So the unit impulse is just there to define the system, to tell you what the system actually does, just like a spike for a short period of time. That's what this unit impulse does. Or you also call it what? A Dirac delta function, or even Dirac itself. Now let's look at the third type of signal, which isn't kind of very important in signal system as compared to the two we discussed previously, which is the word rap signal, even though it is actually very important, right? But not as compared to the unit import, because it's very important, the unit import and also the unit step. We use it for truncating and for knowing the response of a system. Now let's look for the ramp signal. Ramp signal is a signal with what? A slopey value. You look at it, it's ramp, and then if you can, it's kind of like zigzag signal. It's not linear. So there's a kind of a thing with the signal is that it goes in a slopey form, right? It has a slope. Now if it is a unit ramp, it has a unit slope, which means at every point we have a value of unit. Let's say look at this point. If the value is 1, we also have 1. If the value is 2, we have 2. It's kind of is a function of t because it is denoted by r of t, right? R of t from the word ramp, right? It is defined for this. It has a value of t as opposed to the other one that has a value of 1. It has a value of t, and for t greater or equal to 0, so from here upward, it has a value, right? And for t less than, it has a 0 value. That's for the ramp signal, right? Let's look at the next signal, which is the parabolic signal. The parabolic signal is quite same like the ramp signal, right? The only difference is that if you look at the ramp signal, its value is t at t greater than or equal to 0. If you integrate this ramp signal, the t, you are going to get t squared over 2, which is actually the ramp and the parabolic signal. That is why there is some relationship between this signal. And in the upcoming video, I'm going to discuss about the relationship between the signals. Right? You can see that from the ramp signal, the timing, right, t greater than or equal to 0 is the same for both cases. But the only difference is that you integrate this function here and you get t squared over 2. And when you do that, we get a parabolic curve, right? That's another type of signal. It is defined as x of t, and it's denoted as x of t and defined by this, right? Now let's look at the fourth and the fifth signal. The fifth signal is called signum, right? It's defined by SGN of t, if you may call it that way, right? It's defined for this. It has 3 levels or 3 values: a 1, a 0, and a -1. It has a unity value for t greater than or equal to 0. For t greater than 0, and at the origin it has a value of 0. At t less than 0, it has a value of -1, like 3 levels. This one also can be used in some case of what? Truncating, right? Because you force the signal to have either, let's say, at the negative edge, let's say the signal is like this, it's only positive, right? The signal is positive, and then when you kind of mix it up with such kind of signal like this, you kind of force this part to go down. It's kind of, you are forcing the signal to go down, and we have it on a positive edge. That's how the signal, we can think of it again, right? It's kind of also for truncating. Let's look at the last but actually not the least signal, which is the rectangular signal, right? It is denoted as what? Rect of t, and it is defined as rect of t, right? It has a value of 1 for this range between -1/2 and 1/2 and 0 otherwise. That simply means that if you look at this region like this, right, we have 1/2 minus -1/2, which is going to give us 1. So if this side is 1 and the amplitude, which is the top, is also 1, so it is having an area, right? So this one is 1, right? That means the amplitude is 1, and this side is 1. It's having an area of unity, right? The area is 1 for the rect signal. So also this kind of signal can be used for truncating. Assuming there is another signal that will go this way, and we only want the signal to exist for a short period of time or within a range, we can just apply this rect signal to it, right? We mix it up and we end up having something like this, kind of. If we can see, it's within this range, right? You can see it is within this range, so the rest is gone. So if you look at all the signals, they have their use case, but for me the most important one is actually the unit step, this impulse signal. Actually, that's the one you will mostly deal with, and the rest are also useful. in dealing with some complex scenario. But for impulse signal, you will see it most often when dealing with signal problems. You understand? Because we are dealing with actually discrete signal most of the time in signal system. So when you have a discrete signal, it usually exists at what discrete intervals. So a unit impulse exists at 0, 1, so it kind of a spike. Unit impulse also the same. We look at ramp signal, we look at parabolic signal and the rest. If there is any question, feel free to ask in the comment section and I'll be there to answer. Cheers.